Wherever shafts and axles turn, wherever gears mesh, you'll probably find a lubricant of some kind. The main purpose of a lubricant is lubrication. It reduces friction and wear by providing a slippery film between two metal parts. But lubricants provide three other important functions. They help to cool the components. As the lubricant flows around assemblies like axles, it carries the heat away and helps to dissipate it. Lubricants help to keep the components and assemblies clean, with any component debris particles or oil degradation products like carbon, sludge, or varnish being suspended in the lubricant. These contaminants can be strained out using filters, enabling the lubricant to continue to perform its cleaning function. The final function of a lubricant is protection. When metal parts are kept covered in lubricant, that prevents metal-to-metal contact and any resulting damage. We're going to focus on the protection function of lubricants, how oil additives protect gears, bearings, and the oil seals. You can see the damage created when axle components aren't properly lubricated. The faces of the ring gear teeth are badly worn. The damage on the input pinion is even more dramatic, with metal loss on the gear. Without lubricant protection, axle components wear out more quickly and will need to be repaired or replaced. The surfaces of all metal parts, no matter how smooth they appear, actually have small peaks and valleys called asperities. Normally, the lubricant forms a boundary between the two metal parts, preventing the asperities from touching one another as the parts move. Without proper lubrication, the asperities come into forceful contact and actually cold weld to one another. As the parts continue to move, the weld breaks. This releases small metal particles that can cause additional damage to the gears and bearings. Lubricants are formulated to improve their ability to protect the parts from damage and wear in specific operating conditions. Let's look at the typical composition of gear oil. The base oil is the main component. It's from 36 to 96% of the gear oil. There may be no viscosity modifier, or it can be as high as 50%. A pour point depressant may be added, up to 2% of the total oil volume. And finally, the axle oil additives might be from 4 to 12%. Let's look more closely at the additive. These are the functional components that are typically included in an additive package. These additives are what define the quality of the final oil. For example, API GL5 oil quality versus SAE J2360 quality. What function does each additive component perform? The friction modifiers reduce friction and wear during mild sliding contact. Under heavy and medium loads, the extreme pressure and anti-wear chemistries replace the friction modifier. These two components are typically used in combination. They react with the metal to create an easily sheared surface layer. If any asperities do touch one another, they shear cleanly rather than breaking off. This doesn't create metal debris particles. An additive package with all three components provides protection under the full range of gear contact pressures. The next elements of the additive package are the rust and corrosion inhibitors. They form a thin, compact film on the metal surfaces that reduces the dissolution of metal ions into the surrounding environment. This prevents metal loss and avoids exposing fresh metal that would wear more quickly. Dispersants keep dirt and debris particles suspended in the axle oil from sticking together. This keeps the inside of the axle clean and stops the formation of larger particles that could cause damage to gears, bearings, or the oil seals. The final additive is the foam inhibitor. As gears rotate quickly through oil, they can cause foaming. That results in power loss and reduced axle performance. It also breaks up the lubrication layer, leaving metal surfaces unprotected. Foam inhibitors change the surface tension of the foam bubbles so that they break up more quickly. To achieve the desired quality level, whether it's API GL5, SAE J2360, or an even higher level, you must have the right additive package. When formulating axle oils, selecting the right additive blend is essential to match the oil to the application and to achieve the desired performance.